Hi everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. So this video is about 20 questions from control systems for your ECIL examination preparation. You all know that ECIL is going to conduct exam. This is for the first time it is going to conduct. So we based on our past experience and past papers or various other exams, I taken some 20 very good questions for the subject control systems for your ECIL examination, right? So let's enter into the questions. The very first question is the open loop DC gain of a unity negative feedback system with a closed loop transfer function s plus 4 by s square plus 7s plus 13 is asking open loop DC gain. First of all, open loop DC gain. DC stands for DC means put S is equal to 0. Put S is equal to 0. But he's asking what gain? Open loop gain. He given closed loop transfer function. From that, what is the open loop transfer function from the closed loop transfer function? Open loop transfer function is equal to closed loop transfer function by 1 minus closed loop transfer function. If you do this, yes, this is the closed loop transfer function given. Closed loop transfer function, this by 1 minus this, if you do, you are going to get s plus 4 by s square. Yes, s minus 7s minus s, it will be 6s plus, yes, 13 minus 4, it is 9. Now put s is equal to 0. If you put s is equal to 0, you will get simply 4 by 9. Answer is how much? 4 by 9. Option is B. Choice B. Very simple it is. But you must know this relationship. Open loop transfer function is equal to closed loop by 1 minus closed loop. DC means putting s is equal to 0. Let's go to the next question. Negative feedback in a closed loop control system does not. Negative feedback improves stability. Negative feedback reduces the effect of disturbance. Negative feedback reduces the sensitivity of forward path transfer function with respect to the variations, right? Negative feedback reduces the sensitivity of the transfer function with respect to the variation in the forward path parameters, right? And negative feedback is going to reduce the gain. That is only the drawback of negative feedback. Negative feedback in a closed loop control system does not. It will reduce the overall gain. It is going to reduce the overall gain. So this statement is correct, but he is asking does not, means negative feedback reduces the gain, but he is asking not, therefore this is not correct. Reduces the bandwidth, no, it increases the bandwidth, therefore this is also not correct. Improve disturbance rejection, yes, but he asked about does not. Reduces the sensitivity to parameter variation. See, negative feedback in a closed loop control system does not. It is not going to, it is going to reduce the gain. Reduces the, it is going to increase the bandwidth, sorry, here, it is going to increase the bandwidth. See, I'll list out all the things here. Negative feedback, yes, increases bandwidth, comma, decreases time constant, comma, yes, decreases overall gain, decreases overall gain, comma, yes, decreases disturbance, it is going to decrease, disturbance effect, comma, decreases sensitivity. So it is going to improve the bandwidth is going to improve, but here reduces the bandwidth, it is not going to reduce the bandwidth. Option is B for Bombay, right? Next question please. Open loop transfer function of a unity feedback control system is 1 by s plus 2 whole square. The closed loop transfer function poles are, he is asking about the closed loop poles. What is characteristic equation, ma? Characteristic equation is equal to 1 plus your OLTF. What is that? 1 by s plus 2 whole square. The roots of the characteristic equation are nothing but closed loop poles. Characteristic equation is equal to s square plus 4s plus 5 is equal to 0. Solve this one for roots. Solve this one for roots. S1 comma 2 or y2 all that. So 4s, right? So S1 comma 2 is equal to minus b plus or minus root of b square. B square is 16 minus 4ac is by 2a. Now S1 comma 2, 2 poles, minus 2 plus or minus 16 minus 20, therefore that will be j2 by 2. So S1 comma 2 is equal to minus 2 plus j1 comma minus 2 minus j1. Minus 2 plus j1 comma minus 2 minus j1, option D for Delhi. Minus 2 plus or minus j1. Minus 2 plus or minus j1, right? Yes or not? Minus 2 plus or minus j1. Let's go to the next question. The total number of feedback loops of the signal flow graph is where R is the input and C is the output. He is asking about the total number of loops. Feedback loops or loop, both are same. What is a loop? Loop is a closed path which starts and ends at the same node. You see, all of you observe carefully. This is going to be a loop. This is going to be a loop. Yes, it started here, ended there only. Again, this is going to be the second loop. You see the arrow, second loop. And this is the third loop. This is the fourth loop. And if you see, this one is going to be the fifth loop. This one is going to be the fifth loop. Total loops are 5. Option is C. Calculation of loops is very simple. But in the loops calculation, you should not touch any node more than once. Means some people will come up this way. Some people will come up this way. Sir, I will come like this. I'll go like this. I can form a loop like this. No. Because you are coming, you are touching this node, again you are going, again you are coming to the same node, which you should not do. Right? Number of loops are 5. Let's go to the next question. For the network shown in the figure, Vi of t is the input and I of t is the output. The transfer function I of s by Vi of s of the network is asking what is I of s by Vi of s. Now let's write in Laplace transform. In Laplace transform, the resistance is resistance, L is Ls, C is 1 by Cs. This is R, this is Ls, yes, this is 1 by Cs. Total our control systems is discussed in Laplace transform. This is Vi of s. Transfer function will exist only in Laplace domain only. The current is I of s. You tell me, according to Ohm's law, current I of s is equal to voltage divided by R plus Ls plus 1 by Cs. Now I of s by Vi of s is equal to, let Cs goes upside, Cs by LCS square plus SCR plus 1. Cs by LCS square plus SCR plus 1, option is D for Delhi. Right? That much simple it is. Next question please. The signal flow graph, signal flow diagram for a certain feedback control system is shown in the figure. Okay. Now consider the following set of equations for the nodes x1, x2, x3, x4, x5 given. Which of the following are correct? Yes, let's write the equations for all the nodes. Let's write the equations for all the nodes. Right? Now I am writing for x1. I am writing for node x2. Sorry, x2. So one statement here, it is very important, that is the value of a node is affected by only its incoming branches and it is unaffected by its outgoing branches. I repeat, the value of a node is affected by its incoming branches, it is unaffected by outgoing branches. Now x2, what is the incoming? A1, x1. X1 is incoming with help of A1, and what is another incoming? A9 plus A9 x3. Done. Correct only. One is correct. Second one, let's write x3. X3. Come here to the node A2 x2. Yes, A2 x2. A2 x2 is coming. X4 8 or A8 x4. A8 x4. Right? This is one incoming. This is another incoming. Only two incomings. Only two incomings. That is also tallied. Let's write for x4. x4 is equal to a3x3, a3x3, right? Yes, a3x3, a7 itself is coming. See, this is 1 incoming, this is a7x4 plus a7x4, a3x3 plus a7x4 it is. Yes, 3 is wrong. x4 is equal to a3x3. It is not a5, it is a7 plus see, x4 is coming to itself with help of a7 plus x2 a5 plus x2 a5. See, this node x2 is coming with help of a5. This is one incoming, this is one incoming, this is another incoming, right? Therefore 3 is wrong. Let's write for x5, this is the fifth node. What is that? x2 a6 or a6 x2, right? a6 x2, that's all. Plus another incoming is a4 x4. So you see a4 x4 plus a6 x2, this is also correct. Which are the correct? 1, 2, 4 are correct. 1, 2 and 4, option D for Delhi, right? D for Delhi. Come here, let's go to the next question. For a given signal flow diagram, this is the arrow that is missing here. I am writing here. Yes, transfer function is, which is asking C by R is dash, right? C is equal to, this is also arrow. Yes, C is equal to R is coming, C is equal to R is coming, minus plus CH1. Yeah, this H1 is coming to the, see, these are the two nodes R and C. R is coming with help of 1, nothing is there means 1. C is equal to R into 1 plus C itself is coming to that one only with help of H1. Now get C this side. C minus CH1 is equal to R. If I take C by R, that is equal to R by 1 minus H1. 1 by, why R? R is this side, na? C 1 by 1 minus H1. That is 1 by 1 minus H1. Option is C. C for Chennai. 1 by 1 minus H1. Right? Next. The unit step response of a particular control system is given by C of t is equal to 1 minus e power 1 minus 10 into e power minus t. Then its transfer function is. Is asking about the transfer function. Yes. Transfer function is equal to Laplace transform of output 1 minus 10 into e power minus t by Laplace transform of the input. What is the input he given? Step, unit step. Yes, u of t. Now tell me, what is the Laplace transform of 1 by s? Actually it is 1 into u of t. It is not 1 into u of t. Its Laplace transform is 1 by s minus 10 by s plus 1 by 1 by s. So this is s plus 1 minus 10s. Yes, s plus 1 minus 10s. S plus 1 minus 10s by s into s plus 1. 1s has gone. Therefore, 1 minus 9s by s plus 1. 1 minus 9s by s plus 1. Option is C. C for Chennai. Right? Simple question. See, transfer function is Laplace transform of output by Laplace transform of input. Right? Next question. A signal flow graph of system shown in the figure, the number of forward paths and the number of individual loops will be respectively. What is a forward path? Forward path is a path taken from input to output without touching any node for more than once in that particular forward path. In that particular path, what is a forward path? The path taken from input node to output node means you need to move from input to output. In that process, you should not touch any node for more than once. Right? Now, let us see the forward paths. Number of forward paths. Number of, yes, forward paths. Let's see. If you see, this is one forward path. Yes, this is another forward path. Second one, that is, let me go with a different color. This is a third one. This is the fourth one. Fifth, sixth is also possible. Let me erase these things. Then fifth and sixth I will show it to you. You may be thinking only 4. You may be thinking only 4. I will show you the fifth and sixth one also. You see, sorry. No. Yeah. This is the fifth one, you see. I marked it. That is the fifth one, right? Yes or not? That is the fifth one. Same way, from the downside also you get the sixth one. Same way from the downside also, yes, yes, no. Same way from the downside also. This is the sixth one. Forward paths are 6. Let's see the loops. This is a loop. Loop is a closed path which starts and ends at the same node. This is also one of the loop. 2 loops are done. Now let me show you the third one. Let me show you the third one. Right? So this will be the third one. Yes, this is the third one if you observe carefully. Right? 6 and 3 answer. Option is D. D for Delhi. Right? Number of forward paths are 6. Number of loops are how many? 3 we got. Let's go to the next question, please. Next question. Right. From the figure shown below, the transfer function of the signal flow graph is, directly you can write, yes, x2 is equal to t12 into x1 plus x2 into t22, right? X2 into t22. Take x2 that side. If I take x2 common, 1 minus t22 is equal to t12 into x1. So x2 by x1 is equal to t12 by 1 minus t22. t12 by 1 minus t22. Option is A. Option is A. Next question, please. Consider a transfer function h of s, s square minus 5s plus 100 by s square plus 5s 100. The transfer function is what kind of filter is asking. First you replace with s is j omega. S with j omega. If you replace s with j omega, always if you want to find what kind of filter it is, find first its magnitude. First step. Second step is put omega equal to 0, then omega equal to infinity. Check for these two. Then we can go for the third step if it is required. What is this? Minus omega square minus j 5 omega plus 100 by minus omega square plus j 5 omega plus 100, right? I want its magnitude. Yes. What is that? Numerator magnitude. See, if you have a complex number, what is the magnitude root of real part square plus imaginary part square? So 100 minus omega square whole square plus 25 omega square is the numerator divided by, yes, 100 minus omega square whole square plus 25 omega square. This is cancelled 1. Irrespective of the frequency, always the magnitude is fixed. It is a all pass filter. If the magnitude is reducing, low pass, magnitude is increasing, high pass, magnitude is always constant irrespective of the frequency. It is what? All pass filter or all pass system. Next question. The type number of the control system with GSHS is equal to s plus 2 by s into s square plus 2s plus 3 is type. What is type? Type means it is the type. Let me type is the heading. Type. Type means it is the number of poles which are present at the origin of an open loop transfer function. Yeah, this is the open loop transfer function. How many poles are present at the origin? We have s power 1 means 1 pole at origin. 1 pole at origin in OLTF, in open loop transfer function. Therefore, type is equal to 1. Answer is option A, choice A. Answer is what? Choice A, right? Next. As compared to closed loop system, an open loop system is, yes, see, I will tell you one thing. Closed loop sometimes if you are doing it good, then stability will increase, but if you are not doing correctly, stability will decrease. But overall what we have to understand is, if you are making it closed loop, most of the time there is a possibility for the reduction of its stability, accuracy will increase. Option is C. Feedback will decrease stability and increases the accuracy. But negative feedback, if you apply it properly, then it can increase the stability. If you are not applying it properly, stability will be decreased. So generally feedback systems are suffering from the problem of instability, therefore stability decreases. Less stable but more accurate. Option is D for Delhi, right? Let's go to the next question. Signal flow graph can be used to represent. Strictly signal flow graphs are applicable only for linear systems. Yes. Signal flow graph, I am writing in shortcut SFG, are applicable only for, yes, only for linear, or I'll write in shortcut, applicable only for LTI systems only. Right? So linear systems only. So it is not applicable for time varying also, linear time invariant systems only, right? Next question. For the following system is saying, if x1 of s is equal to 0, the transfer function y by x2, okay, apply Mason's gain formula, y by x2. Tell me, from x2 to y, how many forward paths? Only one forward path. Yes, by 1 minus, tell me, how many loops are there? Only one loop. What is the loop gain? Minus of minus s by s plus 1 into 1 by s. This gone. So y by x2 is equal to 1 by s by 1 plus 1 by s plus 1. Now if you do this, you are going to get it as s plus 1, this will go upside, by s into s plus 2, s plus 1 by s into s plus 2. After simplification, choice D is perfectly suitable. Just, sir, how you did it? Mason's gain formula. What is it? Mason's gain formula. Forward path, only one forward path. Delta 1 is 1. Why? Because to that forward path, this is the forward path, to this forward path, this loop is touching. Now what is the downside ones are delta. What is delta? 1 minus sum of all the individual loop gains. Yes, 1 minus, only one loop is there. What is that loop gain? S by s plus 1 into 1 by s, but it is stopping at minus. That minus also will be taken into consideration. We got s plus 1 by s into s plus 2. Next question is, from the signal flow graph shown in the figure, the value of x6 is very simple. x6 is equal to E into x5. But what is x5, sir? x5 is equal to D into x4. D into x4. Sorry, D. It is not DE. D into x4. What is x4, sir? x4 is ax1 plus bx2 plus cx3. Put it there. x6 is equal to E into x5 is D into x4 is ax1 plus bx2 plus cx3, right? So ADE or ED or DE, x6 is equals to, so option is A, DE into ax1 plus bx2 plus cx3, right? Next question. Consider a control system shown in the given figure. For a slight variation in G, the ratio of open loop sensitivity to the closed loop sensitivity will be given by. So he is asking, open loop sensitivity is 1. See, I can write open loop sensitivity is 1. Why? Because if you are leaving this H, G, if G doubles, C also doubles. If G halves, C also halves. Then what is a closed loop sensitivity? closed loop sensitivity will be, see, let me write here, open loop sensitivity is solution, open loop sensitivity is 1 or 100% in terms of percentage. Then closed loop sensitivity will be closed loop sensitivity of what is asking. For a slight variation in G, the ratio of open loop sensitivity to the closed loop sensitivity is given by. So question is not that clear. Let me take a transfer function sensitivity. I am taking at what? Transfer function sensitivity. Whenever G is varying, transfer function will get vary. So let's find closed loop sensitivity. What is that? Sensitivity of transfer function M with respect to G. Then it will be dou M by M by dou G by G, right? So you are going to get this one as what is M? First of all, what is M transfer function? Where M is equal to G by 1 plus GH. G by 1 plus GH. You get it as 1 by 1 plus GH. You get 1 by 1 plus GH. Now he is asking the ratio of this one and this one. Yes, sir, you may be thinking, sir, how you got 1 by 1 plus GH? Just this derivative, dou M by M by dou G by G. Just derivative only. That is very simple thing to do, right? Now he's asking the ratio of these two. Now ratio of these two will be 1 by 1 plus GH, that is equals to 1 plus GH. 1 plus GH will be the answer. See, some of you, why I left this derivative to you? You must do that derivative. That is dou M by dou G into G by M. What is M? I given G by 1 plus GH. Now this G gone. This M is there, no? Now observe here, dou by dou G of what is M? G by 1 plus GH into 1 by 1 plus GH. Just to do this U by V derivative, that's all, right? You will get it as 1 by 1 plus GH. Option B is the answer, right? Next question. The transfer function of the system shown below is O by R. Tell me how many forward paths are there. This is the first forward path. What is that? O by R is equal to AB plus, what is the second forward path? This is second forward path, AC by, yes, how many loops are there? This is one loop. Yes, what is the, let me go with a different color, man. This is going to form one loop, right? This is going to form one loop. What is the loop gain? 1 minus AB. Another loop is, I am going with other color. Observe it carefully. Observe it carefully. So same, this way also loop can be formed, minus AC. So AB plus AC by 1 minus AB, AB plus AC by, yeah, minus of minus will be plus. Here minus is there, na? Minus of minus is plus. 1 plus AB plus AC. Option is B, B for Bombay. B for Bombay. Just Mason's gain formula, nothing more than that, right? Next question. What is the overall transfer function of the block diagram shown in the figure? He's asking about overall transfer function. Here also, just you apply Mason's formula. Tell me, how many forward paths are there? Number of forward paths. I want C by R. I want C by R. This is the first forward path. What is that? Z1, Z2. So this is going to be the second forward path. What is that? Z1, Z3. Right? Any other forward path? No. One first forward path, second forward path, no third forward path, only two forward paths. G1, G2 plus G1, G3 by 1 minus. Any loop formation is there? Any loop formation? Yes, there is a possibility. This is one of the possible loop, only one loop. 1 minus, what is that? G2 H1 minus H1 plus G2 into H1. That's all. G2 into H1. Option A is perfectly suitable. Observe, option A is perfectly suitable, right? See, we solved similar level questions of ECIL examination from control systems, that to basics of control systems, first two chapters. Here in this, some calculations knowingly I left it to you so that you are going to calculate, right? See, Mason's gain formula, will take to understand the total formula, how to apply exactly, what are the limitations, what are the combinations, and all these things to understand it will take half an hour. Here in these questions I discussed about Mason's gain formula overall way, but not in depth. It will take some good amount of time to understand, right? So this way we will be covering all the subjects which are there in ECIL examination. YourPedia started a dedicated module for ECIL examination preparation. You can join your hands with YourPedia to accelerate your preparation towards ECIL examination. If you have any questions related to your preparation or content, whatever it is, you can call to the number that is mentioned in the description. Thank you.